Hello dear students, I welcome you to the new video for the chapter Alcohol, Phenol and Ether. In this video, we are going to study the physical and chemical properties of phenol. So we'll start with the chemical properties. So on the chemical properties, we'll study electrophilic substitution reaction. Now, in order to understand electrophilic substitution reaction, you must know the resonance of phenol. So phenol undergoes resonance to form more than one resonating structures. So these are the resonating structures formed by phenol. Now, from the resonance, you can see carbon 2, carbon 4 and carbon 6 are negatively charged. Carbon 2 is negative, carbon 4 is negative, carbon 6 is negative. Now, if there is an electrophile, the electrophile will always prefer to attack the carbons which are negatively charged. So the electrophile substitution will take place at carbon 2, 4 and 6 depending on the type of reagent we use. So let us see electrophilic substitution reaction with suitable example. So the first electrophilic substitution reaction which we are going to study is nitration. So in nitration, nitro group is substituted at 2, 4 and 6. Depending on the type of nitric acid we used for the reaction, we get different types of products. We can use dilute nitric acid or we can use concentrated nitric acid. The products formed by dilute nitric acid is different from the product formed by concentrated nitric acid. So let us first see the reaction of phenol with dilute nitric acid. So phenol, if it reacts with dilute nitric acid in presence of H2SO4, there are two products formed. In the first product, the nitro group will be substituted at position 2, which is also known as ortho position. So name of this compound, this product is 2-nitrophenol, or is also known as O-nitrophenol. O means ortho. And 4-nitrophenol, this is 4-nitrophenol, is also known as P-nitrophenol. So once again, if you use dilute nitric acid, you will get two products, that is 2-nitrophenol and 4-nitrophenol. Next, if we use concentrated nitric acid for nitration, so when phenol reacts with concentrated nitric acid in presence of sulfuric acid, that is H2SO4, you will get only one product. And in the same product, all the positions which are negatively charged, that is position 2, 4 and 6, are substituted by nitro group. So we get 2, 4, 6 tri-nitrophenol, which is also known as picric acid. Now, next electrophilic substitution reaction which we are going to study is bromination, or in general we can also say halogenation. So in case of bromination, we can use Br2, that is bromine, in presence of different types of reagent. So if you use Br2 in presence of carbon disulfide, that is CS2, you get two products, that is 2-bromophenol and 4-bromophenol. But if you use H2O, that is aqueous Br2, this Br2 in presence of H2O is also written as aqueous Br2, where aqueous means water, that is aqueous Br2. We get only one product, that is 2, 4, 6 tri-bromophenol. 2, 4, 6 tri-bromophenol. So if you use Br2 in presence of carbon disulfide, you get two products, that is 2-bromophenol and 4-bromophenol. But if you do bromination in presence of H2O, that is aqueous Br2, we get only one product, that is 2, 4, 6 tri-bromophenol. Next electrophilic substitution reaction is Phenols reaction. There are two types of Phenols reaction, that is Phenols alkylation In Phenols alkylation, we add alkyl group. So phenol will react with an alkyl halide, so CH3Cl, in presence of an anhydrous aluminum chloride, which will act as Lewis acid. So the electrophile here is the methyl group, that is CH3. So CH3 will attack position 2 or position 4. That means we'll get two products. Now what if it attacks position 6? The product will be same as when it attacks position 2. So we'll get 2-methyl phenol and 4-methyl phenol. Next, let us see Phenols acylation. In Phenols acylation, we'll add acyl group, that is alkyl with CO, is known as acyl. So in this reaction, we'll let phenol react with acyl chloride like CH3COCl in presence of anhydrous aluminum chloride. Here also you'll get two different products. Acyl group will attack carbon 2 or it will attack carbon 4. Next, let us study the oxidation reaction of phenol. Phenol, if it is oxidized using strong oxidizing agent, that is K2Cr2O7, potassium dichromate, in acidic medium, we get benzoquinone. This is the product form, this is the structure of benzoquinone. So this is the oxidation reaction of phenol. Next, we'll study ether. Ether is a compound where two alkyl groups are linked to an oxygen atom. Now, this oxygen is known as ethereal oxygen. The two alkyl groups, it can be same or different. So depending on that, it is classified as simple or symmetrical and mixed or unsymmetrical. Now, if both the alkyl groups are same, the ether is known as simple ether or symmetrical ether. If they are different, it's known as mixed or unsymmetrical ether. So let us take example. So CH3 O CH3. So this is the ethereal oxygen. You can see the alkyl groups, methyl is same on both sides, so is known as simple ether. Whereas if you take CH3 or C2H5, you can see the alkyl groups are different, so this is mixed ether or unsymmetrical ether. Nomenclature. Let us see how to write the names of ethers. So there are two types of name. There is common name and IUPAC name. Common name is written as alkyl ether, whereas IUPAC name is written as alkoxy alkane. CH3 or CH3. Now this is an example of simple ether. So on both sides you have the same alkyl group, that is methyl. The common name for this ether is methyl. Here also you have methyl. So instead of writing methyl twice, we'll use the prefix di. So this is dimethyl ether. When we write the IUPAC name, we write it as alkoxy alkane. So one of the alkyl group will take the oxygen and will act as alkoxy, whereas the other alkyl group will act as alkane. Now in this case, in this ether, you can see on both sides we have the same alkyl group. So anyone can act as alkoxy. Now say this CH3, if it takes the oxygen, CH3 is methyl, but with oxygen it will become methoxy. One carbon, alkane name is methane. So the name of this ether, the IUPAC name is methoxy methane. CH3OC2H5. Now here, the alkyl groups are different. CH3, C2H5. Now when we have different types of alkyl group, we cannot use prefix like di, tri, tetra. So in this case, what you have to do, we have to write the names of both the alkyl groups. And the names will be written in alphabetical order. C2H5 is known as ethyl. CH3 is known as methyl. So methyl M, ethyl E. Alphabetically, ethyl will come before methyl. So the common name for this ether is ethyl, methyl, ether. Our PC name. Now in case if we have different types of alkyl group, the smaller alkyl group will act as alkoxy and the bigger alkyl group will act as alkene. Now if you compare CH3 size is smaller than C2H5, so CH3 will act as alkoxy, that means will take oxygen, and C2H5 will act as alkene. So the name of this compound, the RPC name is methoxyethane. Now here, we have two different types of alkyl groups. This is ethyl. Here we have 1, 2, 3, 4, 5 carbons. Now when we write the RPC name, we have to count the longest possible chain. Now first of all, this is the smaller alkyl group, so this will act as alkoxy. This alkyl group will act as alkene. So first we'll write the alkoxy part, that is ethoxy. Now since you have a substituent in the alkene chain, now we need to mention the position of the alkoxy group also. So say this is carbon 1, carbon 2, carbon 3, carbon 4. So 1 ethoxy, 3 methyl. 1, 2, 3, 4. 4 carbon, alkene name is butane. Now here, what is the RPC name of this compound? Again here, this will be alkoxy, alkene. So name of this compound is methoxybenzene. Next, let us study the preparation of ether. So there are two very important methods for the preparation of ether. First method is by dehydration. Dehydration of alcohol. So in dehydration reaction, we take 2 molecules of an alcohol, C2H5OH. We'll have to take 2 molecules, and this alcohol will undergo dehydration reaction. So the reagent for dehydration reaction is concentrated H2SO4, that is sulfuric acid, at 413 Kelvin temperature. So it will release H2O and will form this ether C2H5O C2H5. So the name of this ether is ethoxy ether. Now the second method for the preparation of ether is Williamson's synthesis. In this method, an alkyl halide will react with sodium alkoxide in dry ether medium to form ether. So you can take any alkyl halide, let us take CH3, Cl, sodium alkoxide, let it be C2H5ONA in dry ether medium. So here the sodium will take Cl, that's chloride, and will go out as NaCl, that is sodium chloride. And we'll get the ether, that is C2H5OCH3. And the name of this ether is methoxy ethane. Now, the advantage of Williamson synthesis over dehydration is, by Williamson synthesis, we can prepare both simple and mixed ether. But by dehydration method, we can prepare only simple ether. So for the preparation of ether, if it is mixed ether, you have to follow Williamson synthesis. Now a question may come like, convert ethanol to ethoxyethane, or what happens when methyl chloride reacts with sodium ethoxide in dry ether medium. Or you might be asked direct question like, explain Williamson synthesis. Or you might get complete the reaction, you'll be given the reactant, you'll be given the reagent, you'll have to write the product. So you have to practice the reaction if you want to do well in organic chemistry. Next, we'll study the physical properties of ether. So when it comes to physical properties, number one, solubility. Solubility in water. Now ether, ROR. Now since you have alkyl group on both sides, it's not possible for them to form effective hydrogen bonding with water. So that's why they are insoluble in water. Next, boiling point. Now when it comes to boiling point, for ether also the boiling point will increase with the increase in size. So if you compare CH3O, CH3 and CH3O C2H5. If you compare these two ether, the boiling point of methoxyethane will be higher than methoxymethane. Similarly, if we consider a series of ether, the one having maximum size will have maximum boiling point. So from here, you might be given different types of ether and you'll be asked to arrange them in increasing order of their boiling point or decreasing order of their boiling point. Next, we'll study the chemical properties of ether. So when it comes to chemical properties, number one, a reaction with HX. So CH3 or CH3, if it reacts with HX like hydrogen halide, so let us take HCl. Now here, the carbon-oxygen bond will break. So oxygen, carbon. So if this bond breaks, carbon will be positive, oxygen will be negative. So the oxygen being negative will take the positive part from HCl, that is H, and will form CH3OH. Plus CH3 being positive will take the negative part, that is Cl, and will form CH3Cl. So ether, if it reacts with halogen acid like HCl, HBr, HI, it will form alcohol and alkyl halide. Let us see one more reaction. CH3, 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 O, CH3. So this is an example of mixed ether. Now, there are two possibilities here. If you break this bond, this carbon will be positive, oxygen will be negative. But if you break this bond, oxygen negative and this carbon will be positive. Now if you know the order of stability of a carbocation, the stability of carbocation is 3 degree carbocation is more stable than 2 degree carbocation, and 2 degree carbocation is more stable than 1 degree carbocation. Now if you break this bond, 1 degree carbocation will be formed. Whereas if you break this bond, 3 degree carbocation will be formed. So breaking of this bond will be preferred. So we'll get CH3, 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 carbon being positive will take the negative part, that is Cl, plus you will get, thank you.